friends, and welcome to Doubt Forum. Today we are going to take one question in which we would be using several concepts related to friction, tension in the string, pulley system, and motion of a block. So let me first read the question. A system consists of three identical masses M1, M2, M3 connected by a string passing over a pulley P. The mass M1 hangs freely and M2 and M3 are on a rough horizontal table. The coefficient of friction is given as mu. The pulley is frictionless and has negligible mass. We have to calculate the downward acceleration of mass M1 in terms of g. So this is mass M1. In order to solve this question, we would require certain concepts. So first we would learn those concepts. I would list down the concepts that are going to be used. First is friction. Friction and its type we would briefly discuss. Then we would also require concept of tension in a string, pulley string system, the significance of massless string, inextensible string, frictionless and massless pulley. So about tension, about the pulley string system, we have already discussed in detail in one of our earlier videos. The link to this is given in the description. Please refer to that and you learn those concepts first. Here friction is the concept that is going to be used for the first time, so we would discuss a little bit about friction. So first of all we would learn about friction. Friction is a force which opposes relative motion between two objects. It is a type of contact force. So, suppose this is ground and this is human foot. Somebody is wearing shoe and this is human foot. What happens? This human foot would push the ground backward. Suppose the person is facing in this direction and wants to move to this direction. So they would push the ground in the backward direction. So the ground would apply an equal and opposite force on the foot as per Newton's third law of motion. So on the foot this force would be acting. If we break, so there would be two components of this force. So this is called normal reaction and this is called friction. The force applied by contact surface along the contact surface in the direction of contact surface is friction, and perpendicular to the contact surface is called normal force or perpendicular force. So this is friction. The basic tendency of force of friction is to oppose the motion. Now we would learn types of friction. There may be several types, but we are concerned mainly with static friction, which is a very important concept, static friction. Then we would learn sliding friction. Then there is another category called rolling friction. So let us learn static friction. Static friction means that two objects are not yet in relative motion. There is a tendency to have some relative motion, but actual motion has not started. So the static friction is never constant. Static friction force is a force which varies and adjusts itself according to the external force up to certain limit. Suppose this is ground and there is a very heavy object of say 10 kg. 10 kg means 100 Newton. Its weight would be 100 Newton. So this is kept on the ground at rest, no problem. There is no net force in the horizontal direction, so there is no motion at all. We apply a force of 1 kg or say 1 Newton. We apply a force of 1 Newton on this object, external force. Do you think this block would start moving? No, it is still too heavy. Why would it not move? When there is a force of 1 Newton, we always know when there is force, when there is net force, there is displacement and acceleration. But still it is not moving. It means the moment you apply 1 Newton force, there is a tendency in the block to start its motion with respect to ground or surface or table, whatever it is. So immediately the table would start applying a force of friction on this block, which would be equal to 1 Newton. And this force of friction would be in the opposite direction of the impending motion. So net force becomes 0 on this block, 1 Newton external force and 1 Newton friction. So net force 0, so this block would not move. Now we make this 2 Newton, still the block would not move. The moment you make it 2 Newton, immediately the static friction would readjust itself and it would make itself 2 Newton. Again net force would be 0. You make it 10 Newton, the static friction would make itself 10 Newton. It would increase to 10 Newton. But there is a limit. Suppose say at 20 Newton the block starts moving. So it means the static friction has a limit of 20 Newton. Just an example. It is not so that it would have a limit of 20 Newton. So there has to be a limit 1, 2, 3, 10. Finally a limit would reach when static friction cannot increase itself automatically beyond that limit. So 20 Newton, suppose we set the limit, we assume the limit to be, then the moment you apply a net force of 20, external force of 20 Newton or more, the block would start moving. So this is why it is called static friction. After that, friction would become constant. It would not increase more than 20 Newton. So static friction is the friction which is applied by the surface on an object when there is a tendency for the motion between the two objects, but the actual motion has not started. And the static friction would have a variable value. Its value would adjust itself according to the external force applied up to certain limit. Next is sliding friction. Sliding friction is the friction when there is actual motion between the object. So up to the point this block was stationary, static friction was acting. When this block starts moving, the force of friction would become constant, suppose 19 Newton or 18 Newton, whatever it is, and that would be called sliding friction. So at that time the block is sliding on this surface. There is actual relative motion between the two objects. Third is rolling friction. Rolling friction comes into picture when a body rolls, cylindrical or spherical body rolls on a surface. So suppose there is a cylinder or there is a ball of a spherical shape and it is suppose rolling. It is rotating about its axis and rolling. So when it is rolling, there would be some friction between the surfaces at the point of contact. This would be called rolling friction. We should always remember that rolling friction is one of the smallest category of friction. That is why if you want to slide an object, it would take much more effort than when you are actually rolling the object. So this is why we take heavy weights on a truck or a tractor or any vehicle and then we transport it. We do not actually push the heavy weight and slide from position A to position B. Rather, we prefer to load it on a cart or on a tractor or on a vehicle and then we transport it, because the friction applied on the vehicle between its tires and grounds would be rolling friction, which is much smaller as compared to sliding friction. So for all these category of frictions, the formula of friction is force of friction is equal to coefficient of friction multiplied by N. N is the normal reaction. This is simple. Force of friction is equal to coefficient of friction multiplied by normal reaction. When we are talking about static friction, so we would say static friction is equal to coefficient of static friction multiplied by normal. When we are talking about rolling friction, we would say rolling friction is equal to coefficient of rolling friction multiplied by normal force or normal reaction. When we are talking about sliding friction is equal to coefficient of sliding friction multiplied by normal. So this is a common formula for all kinds of frictions. Using this we can solve any question. So let us now start solving the question. The other concepts used in this question we have already discussed in another video as I described, so you can refer to that. Here we have this table and we have, the question says 3 identical masses. So first thing is M1 and M2 and M3 are identical, which means these are not different values, but these are the same value. So let us assume it to be M. This would make our calculations easy. Then what we would do, we would draw free body diagram for each of these objects, or for each block and component of this arrangement. This is a table, this is a frictionless pulley, there is one block, and there is another block. When we discussed the concept of string and pulley system, we had explained that when the pulley is frictionless, the tension on the same string, on both sides of the pulley would be same. If tension on the string is T here, the same tension T would be there, because the pulley is frictionless. If there was friction in the pulley, then the tension on both the sides would be different, T1 here and T2 here. But okay, pulley is frictionless. What about this mass? This mass is lying on a table, and there is force of friction between this surface. So when this string pulls this mass to the left side, there would be friction which would oppose this motion. That is the reason this string and this string are separated by a portion where force of friction is working. So tension cannot be the same at this point and at this point. That's it. So we assume for this portion the tension is T1, say T1. So here also the tension would be T1 on this portion, because pulley is frictionless. But in this part of the string, we assume the tension is T2. Now we draw free body diagram. What happens? It is asking, the question is asking, find out the acceleration of this mass, hanging mass, when it is falling down. So when this mass is falling down with an acceleration of A, the string is connecting this mass as well as this mass, and we assume the string is inextensible, it will not extend, its length is constant. So if A is the acceleration on this mass, A would be the acceleration on this mass as well to this direction, and A would be the acceleration on this mass in this direction. So magnitude of acceleration would be the same for string and for all the 3 blocks. The direction may be different. This acceleration is downward, this acceleration is to the left side. Now we draw free body diagram. So small m, let us make FBD for this one, M1. What are the forces acting on this? Gravity or its weight. M is the mass, so mg would be the force of gravity. We have replaced M1 with M because all the masses are alike. Mg would be the force. Also, this block is tied with the string. It means the string is under tension, so the string would be pulling this block upwards with the force T1, which is equal to its tension. So upwards there is a force of T1, right? Now, this block is moving downwards with an acceleration of A. It means the downward force is larger than the upward force. That is why there is a net force in the downward direction, and that is why there is a net acceleration. So the net force would be mg minus T1, and this net force would be is equal to mass times acceleration as per Newton's first law. Net force is equal to mass times acceleration. Now we draw free body diagram for this M2 block. So this is M2. Let us see what are the forces acting on this block. This is connected with this string. So string would be applying or pulling this block with a force equal to the tension on the string. So left side there would be T1 force acting on this block. Again, this block is connected on the right side as well with another string, and because there is a friction here, so this side the tension would be different. So string would be pulling this block to the right side. So on this block there would be a force to the right side which is equal to T2, the tension in the second portion of the string. Third is the weight of the block, because this is a block, so weight of the block would always be acting, which is equal to mg. M1, M2, M3 all are same, so this would be mg. If weight is acting, then table would also be applying a normal, so there would be some normal force N. So these are the forces on the block only, right? So N is the force on the block applied by table. One more force is there because the block is moving in this direction. So the surface of the table would apply a force of friction backwards. It always opposes the motion. So since the block is accelerating in this direction, so friction would be acting in this direction. So T2, and there would be one more force which is small fs, sliding friction. That's it. So N would be equal to mg because there is no motion in the vertical direction. So N is equal to mg. They are balancing each other, so no net motion in the vertical direction, no net force in the vertical direction. T1 should be very high in magnitude. That is why it is able to counter T2 and Fs and is still able to take the block to the left side. Block is accelerating in this direction with an acceleration of a. So we would say net force to the left side is T1 minus T2 minus Fs. This would be ma as per Newton's second law of motion. Net force is equal to mass times acceleration. T1 minus T2. Friction is mu times n. Mu times n is equal to ma. Friction is always coefficient of friction multiplied by normal reaction. So this becomes T1 minus T2 minus mu. N is equal to mg. Mg is equal to ma. This is equation number 2. Now we draw the free body diagram for this last and third block. So this is the last block. Again, weight mg would be acting downwards. Table would be applying a force normal. So N would be the force upwards. To the left side is string. It is attached to the string, so string would be pulling this block with the same amount of force as tension in the string. So T2 would be the force to the left side of this block. And when this block starts moving to the left side, this table, this contact surface would apply a force of friction in this direction. So this would be the force of friction or sliding friction. Same thing, no net motion in the upward direction or vertical direction, N is equal to mg. There is a net motion in this direction. The block moves at an acceleration of a to the left side, just like this one. So we would say T2 minus Fs. T2 would be more than Fs. So this is the net force, and this would be equal to mass times net acceleration. T2, force of friction is mu times N, and N is nothing but mg is equal to ma. This is equation number 3. That's it. We created 3 equations, and now we can solve. We have to find the value of a, so we have to eliminate T1 and T2. T1 and T2 is our assumption. So you can see, if we simply add equation 1, 2 and 3 together, T1 is in minus here, T1 is plus here, T2 is minus here, and T2 is plus here. So automatically T1 and T2 would be eliminated. So we simply do equation 1 plus equation 2 plus equation 3. We simply add them. We add left hand sides of all these equations to the left side, and we equate it to the right hand side, addition of all the right hands. So this becomes mg minus T1 plus T1 minus T2 minus mu mg plus T2 minus mu mg, this is the total left hand side sum, equal to right hand sum is ma plus na, which is 3ma. T1 cancels T1, T2 cancels T2. To the left side we are left with mg minus mu mg 2 times, equal to 3ma. So we take mg outside, this becomes 1 minus mu mg 2 mu equal to 3ma. M cancels m, so we take a is equal to g times 1 minus 2 mu upon 3. This is the option, this is the answer. So let us quickly review. In this problem, first we discussed the concept of friction. Friction is a force that opposes the relative motion between two objects. It acts parallel or along the surfaces of contact. Friction is a type of contact force. Broadly, there are three categories for solid objects: static friction, sliding friction, and rolling friction. Static friction is the force of friction when there is a tendency for movement between two objects, but there is no actual relative movement, only tendency is there. Static friction is never constant. Its value keeps adjusting itself. When there is no external force, static friction would be 0. As there is some external force, static friction of the same amount would be applied automatically on the object, so that net force becomes 0 and the object doesn't move. As we increase the magnitude of external force, the static friction also increases itself to a certain limit. Then it reaches a certain limit beyond which it cannot increase itself. After that, you increase the external force and there would be a net force and the body would start moving, and then the friction would change from static to sliding. Sliding friction is the friction that is applied by the contact surface when there is actual relative motion between the two objects. Then there is rolling friction. When a car is moving on a road, the tires are actually rolling on the surface of the road. So this kind of friction between tire and road is called rolling friction. And rolling friction is far less in magnitude than static or sliding type of frictions. For all these three categories of friction, one common formula is force of friction is equal to mu n. Mu is the coefficient of friction and n is the normal reaction. To solve this question, we also use the concept of pulley and string system, which we have explained earlier in one of our other video. We started solving this question. So in the problem it is said that this mass would start falling downwards with an acceleration of a. So we have to find the value of this acceleration in terms of g, acceleration due to gravity. Because all the three blocks are tied by an inextensible string, so whatever acceleration or velocity or displacement takes place in this block, the same magnitude of displacement or velocity or acceleration would take place in both these two blocks as well. Direction can be different, but magnitude would be the same. So if a is the magnitude of acceleration for this block downward, a would be the acceleration for this one, and a would be the acceleration for this one to the left side. We draw free body diagram. Before that, we consider the tension in strings. So as explained earlier, when the pulley is massless, the tension on the string on both sides of the pulley would be the same. So for this string, it would be T1 here and T1 here. But for this string, it would be T2, because this portion of the string and this portion of the string are separated by a system where force of friction is applied by one surface to other. So tension would be changed. We draw free body diagram for this block. Downward is mg, its weight. String would apply a force equal to its tension on the block, so minus T1, and mg is larger because it is moving downward, so mg minus T1 force is equal to mass times acceleration, first equation. Then we draw free body diagram for second object. Weight is acting downwards. the surface would apply a normal upward. T1 would be the tension because of the left side of the string applied on the block, and T2 would be the force applied by the right side string due to its tension T2. So T1, T2. Also, when the block starts moving to the left side, the friction would be opposing its motion and it would be applied to the right side by the table on the block. So we have these forces. N and mg would balance themselves because there is no net force in the upward direction. And for the left side, T1 would be higher because block is moving in this direction, in the direction of T1. So T1 minus T2 minus Fs would be equal to mass times acceleration. Net force is equal to mass times acceleration. And friction, we put the value mu n, we find equation 2. Similarly, we draw the free body diagram for block 3. We find another third equation from here. We add all these three equations. This way T1 and T2, which were our assumed parameters, they would get eliminated, and then we can find out the value of acceleration A in terms of g, which is A is equal to g 1 minus 2 mu upon 3. You understood this concept and the solution for this problem. Thank you.